leadership fellow. I love to solve problems and really consider myself a Jack or Jill of all trades, and like to dabble in full stack. But my primary focus is in delivering back-end solutions and site reliability and infrastructure engineering. I have a lot of experience with deploying and building cloud-native applications, as well as migrations from legacy on-prem solutions to the cloud. And all of these cloud experiences have enabled me to develop a tool set that I'm really excited to share with you all today. So the agenda for today, we are going to keep it pretty high level. We're going to talk about when, where, and why you might use these three tools, going into understanding our why, breaking down how you can think about infrastructure delivery, and looking really in depth at Ansible, Packer, and Terraform, and then seeing it in action. We won't necessarily get to the nitty-gritty and all the awesome details of these three tools and how you can build some amazing infrastructure with them, but you at least will have a starting point of where to research more, figure out how you can integrate these tools into your own infrastructure stack, or even how you approach, how you think about delivering your infrastructure capabilities. So let's dive right in. First and foremost, we really have to understand our why. This drives the tools that you're picking and the choices that you're making. And ultimately, I just really like to understand why I am using something before just diving right into it. So what's our why for these three tools? This is almost always my go-to answer. We want to build amazing software that's reliable, it's secure, it's highly available and fault tolerant. It's maintainable and extensible amongst the team of engineers that are working on it. It meets our customers' needs, right? And in order to maintain this high bar for our solutions that we're giving to our customers, we can't just stop at applying these principles to our application code. They need to bleed directly into how we look at the infrastructure that is running and powering our application code. So we really have to start to think about our infrastructure as code. And again, maintaining those same practices and mindsets about our infrastructure that we do with our application code. So this code should be tracked and shared and in a version control system so that it's auditable. I know who opened up my firewall or closed the firewall or made a DNS configuration change that broke everything. I know exactly what's running in production, how many boxes are running in QA, because it's all bundled together in a version control system. It also needs to be maintainable and readable. There's nothing worse than not being able to dive right into contributing something or implementing idea because you don't know where to start, or the new team members that you've brought in and onboarded don't know where to start. But it's so frustrating to look back at your own code and not be able to understand what all you have going on, right? So we really need to focus on maintaining that maintainability and readability so that it can be extensible by any one of our team members. There should also be a step-by-step repeatable process that I can follow to build my infrastructure in various environments. And building on top of that repeatable process, automating it, right? My team will tell you I am the queen of fat fingering anything. And the few times that I have to log into a box and hand cram some configurations or manually click through some screens, it always results in a typo. And not only do I fat finger a lot of things, I also can't pick up that I fat fingered something. So I'm running around like a chicken with her head cut off, like, what's wrong with my infrastructure? It's probably because I typoed something. Automation prevents any human error from happening. And quite frankly, it gets our releases to production and building different environments much quicker. When you have an automated, repeatable process, you can not only provision a production environment, but you can provision your performance testing environment that matches production. You can provision a slightly smaller QA and dev environment. So have you, and it's quick, it's ready to go. You're able to get it done. And finally, Just like with our application code, we are testing to make sure that we are meeting our functional and non-functional requirements. We're adhering to the standards that we've set for our application code. We want to apply that same testing mindset to our infrastructure. And these tools that you choose enable you to test in an automated fashion or run tests within the tooling itself. So now that we have in our minds that we're thinking of our infrastructure as code, we can start to look at how we deliver this code to production. What are the components to our infrastructure delivery? Just like you have an API and a front-end UI component to an application, and you usually decouple those components and they have different languages and tooling that they might use, we can break down our infrastructure delivery into components and think about different tooling and technology that we can use to service those components. So I want you to think about resource creation. And when you think of resource creation, we're thinking about the physical items that you would normally be provisioning in your data center, so to speak. So your compute resources, like if you're running in AWS, maybe your EC2 instance or your auto-scaling group. If you're running in Google, it might be Google App Engine or Google Compute Engine. You want to think about the data stores that need to be created in order to serve up data to your application, your relational data stores, your NoSQL data stores, your object store. What about your load balancers that you need to distribute your traffic across all of your instances? And not to mention some third-party connections like maybe Cloudflare that is helping serve as a WAF in front of your application or as a content distribution front end. So resource configuration or creation are those traditional pieces that you're thinking about when you're creating what is running your application. On the flip side, we have application configuration. Most times when you're deploying your application to whatever resource you've created, you're not going to be able to run right out the bat. You might need to install a language. Maybe you need Java running or Node on your box. Or if you don't need to install a language, because you could argue that you're running with containers, at which point you might need Docker installed on your cluster. Or maybe you need a container orchestration system like Mesos and Marathon or Kubernetes. Those are the things that are enabling our application to run that aren't necessarily our application code, but need to be configured and set up. They can also be things like your Datadog agent. So an agent that's going to be able to capture data that you're going to ship back to in order to look at monitoring and logging. Or configuring things like log rotate so that your box doesn't fill up disk space with the logs over many days of running. So now that we understand that there are these pieces and parts to our infrastructure delivery, this is where the good stuff comes in. Ansible, Packer, and Terraform help us implement our infrastructure as code, check off the boxes of secure, reliable, maintainable infrastructure, and deliver those pieces and parts, the resource creation and the application configuration. So let's dive a little bit into these tools and technologies. First and foremost, we have Ansible. On here, you will see this definition straight from the Ansible playbook and documentation. Ansible is an open source software provisioning, configuration management, and application deployment tool. It can run on Unix systems, and it can configure Unix-like and Windows systems as well. When you think of Ansible, I want you to think of configuration management. It's how we provision all of these services and components that we need to run our software. So we're looking at this infrastructure delivery breakdown. We're talking about the application configuration side of things. So again, installing tools, configuring procedures, installing languages, starting and stopping services. So a quick look at Ansible in depth. And again, if you click on my face, it'll make the code screen a little bit bigger for you to see. Up here, we have our playbook. And this is taken straight from the Ansible documentation, and it has multiple plays within it. I love the Ansible terms that they use, the playbooks and the plays. It's really cute. But here we're building the components we need to service our application. So we have a web server play that is going to run to install the components needed for our web server. So we install Apache, the latest version of Apache, with our yum installer. And then we configure that Apache server by copying over a file from its source in our code to the destination on the box. And it's that simple. You can read it. You know what's happening here. One of the reasons why I really love Ansible. And then we move on to our database play. So being able to install Postgres and get the latest version, and then start Postgres so that I can serve up the data layer of my application. Quick high-level look at Ansible in code. Why might you decide to use Ansible? Again, you saw on the previous example that clear and concise YAML syntax goes back to enabling our maintainability, our readability, and extensibility. It also has a really nice, clean hierarchical design that we'll see later on in the demo that allows for reuse and reduction of dry, or increasing your dry, so not repeating yourself throughout your code. It really simplifies some complex configuration logic. As someone who has built many different servers with a lot of complexity and seen comparisons from different tools that you can use, it's really straightforward and simple to use out of the box with Ansible. You don't have any extra daemons, agents, and special servers required to run this tool. And they have phenomenal documentation, which we'll talk about in the next example. So a really quick look, there's several choices that you can use to configure your application configurations. In this talk, we're going to talk about Ansible, Bash, and Chef, very popular choices there. So we have an Ansible example where we are going to try and mount an EBS volume to our EC2 instance. You can see here, we're waiting for our device to exist. So we're waiting for the presence of this EBS volume. And then I need to create a file system for my volume. Pretty straightforward there. And then I'm going to mount my EBS volume to a mount data directory. And then I'm going to create another data directory within that mounted volume. And I'm going to give it some permissions and some ownership from the Kafka user and group. And it's that simple. I've just like that mounted an EBS volume to my EC2 instance. Conversely, when you look at our Bash example, there are a couple things that you have to note here. It's not as readable. It's not as clear. So here I have to add, this comment on that I'm checking for my data volume. One of the cool things that you have with Ansible is you have built-in documentation. When you look at this having to define a name makes you define the documentation and increase that readability. You don't necessarily have to do that with Bash. Someone left off this comment here, you would have to go and search some documentation and remember what -A and -B do. And quite frankly, I don't even remember off the top of my head. And then you really have to understand and probably do a little bit of research on the different Linux commands that you're going to be able to use in order to make your file system, then create a directory and mount that device to the mount path. It's just a lot less readable, and I'm just really not a fan of Bash. And then Chef comes into play. So here we're doing the same thing, waiting for our device to be attached, creating a mount point, running a command. So you can see in our Chef, we're just executing the same command that we have in our Bash scripts. And then mounting that device there. Chef, you have to understand Ruby. So if someone's not familiar and well-versed in Ruby, you're gonna have to ramp up to learn that. And Chef and Bash both don't have out-of-the-box examples. So when I was Googling, because I primarily work with Ansible and Bash and haven't worked with Chef before, it took me about 10 minutes to find a valid example of how to attach this data volume to my EC2 instance. Whereas literally you can type in Ansible, make file system, or Ansible, attach EBS volume, and it will come up with an example in no time. So those kind of highlight the benefits of using Ansible versus Bash versus Chef. But we have to take into consideration that these are just guidelines. If your team is well-versed in Ruby, it probably might make more sense for you to use Chef, right? All right, moving right along to Packer, another plopped definition from the Packer website. And Packer is an open source tool for creating identical machine images for multiple platforms from a single source configuration. So when you think of Packer, I want you to think of kind of the same thing that you thought about with Ansible, in that it is a configuration management tool. It's going to enable us to install and download and package up anything that we need to for our application to run. But on top of that, it's going to bake it into a machine image. So we look at our infrastructure delivery methodology. It's sitting on this application configuration side of things. And you might be like, whoa, 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 Brie, you just said Ansible was for application configuration and Packer's for application configuration. Why wouldn't you just use Packer instead of Ansible? This is where we need to talk a little bit about baking versus frying. So this is just like a fun, I'm not 100% sure if this are even like industry standard terms, but it's a great way to visualize these concepts of when you are provisioning your infrastructure. Are you doing configurations before provision time, so before your instance comes up, or at provision time? So when you think of baking, I want you to think of compile time. So prior to your infrastructure being provisioned, we are going to bake in all of the product and tool and language installations into an image. These should include things like installing products or static configurations. I know that on any box, whether it comes up in my dev region, comes up in my QA region, it comes up in East, West, you name it, that I will always need Cassandra installed. And I will always need Java installed. And while we're at it, I always want to set up log rotate to clean up my log images after 30 days. Like that should hold true no matter what. And I want to bake that into a machine image so that I can cut down on my provision time. If you think about Black Friday, our application is getting slammed and we need to provision 3 new nodes in order to handle the traffic. If I have to wait 15 minutes for you to download Java, download Cassandra, do some additional configurations, and then do more configurations on a per instance level, that's a lot of time. And you can cut down on that provision time by spinning up your infrastructure with a baked image and shave off, 5, 10, 15 minutes and just have to do the configurations that are at runtime. So when you think about frying, we're thinking about those runtime configurations that are needed. So at infrastructure provision time, when your node is coming up, what do you need to configure? So these are all dynamic. Is there a different change that you might have for your dev versus QA region? Maybe you have a different API key, or maybe you need the IP address of the node that's come up. There's no way for you to know what IP address you're going to get ahead of time unless you are statically hard coding that, and that's a whole nother conversation on what we shouldn't do. But there's no way for you to know the IP address of your box prior to it coming up. So any configuration that's dependent upon that needs to be dynamically done at provision time or runtime. So now that we got that cleared up, let's take a look at Packer. You can see here we have a little bit of setup for my AWS environment. I've obfuscated in all these examples some identifying information. And then I pull in what AMI or base image I want to build my application on top of. So here I'm using Ubuntu. There's an owner tied to that relationship, and you have to tell it a little bit about what type of instance you're provisioning and going to be baking in. And then we have this provisioners area, and this is where you're doing that application configuration. So you might be installing Postgres, for example. In our later example, we'll see how you can use Ansible in this provisioner section to help with that configuration. So it's really clean, JSON, pretty nice to read. So why are we using Packer? Again, reducing that provision speed with our baked images. Super critical, and quite frankly, eliminate some annoyance as you're waiting for your boxes to come up with the reduced provision speed. It's super easy to implement. Like we saw that JSON, almost every engineer has JSON in their back pocket. There's nothing to learn here. It's cloud agnostic. And I say this with an asterisk anytime I say cloud agnostic. These tools, while they can be used to provision infrastructure in AWS, GCP, or Azure, you still might have to make some changes to your configuration. So for example, clearly you wouldn't have an AWS access key and secret key if you were provisioning for GCP. But it enables you to not have to learn another tool or another way to do something because you've been vendor locked into the way that AWS implements their baking images. There's also a really cool automated smoke testing feature that you can get here. And rounding out the triple threat, we have Terraform, another definition taken from the Terraform website. It is an open source infrastructure as code software tool created by HashiCorp. It enables users to define and provision a data center infrastructure using a high-level configuration logic. So when you think of Terraform, we want to think about provisioning the hardware, air quotes, because we're in the cloud, right, that is needed to run our software. It is enabling us to provision and spin up new resources for us to consume. So when we look at this infrastructure delivery model, we're thinking about the resource creation side of things. So remember, your nodes, your data center, or your data stores, your network, and your security, and your load balancer. Another caveat here, sometimes if you think really in depth, you might, for example, provision like a load balancer, and then you might configure it a little bit. So the delineation between resource creation and configuration is a little blurred, but for the sake of this talk, we're going to say when you're creating load balancers and all these resources, that even though you might have to do a little bit of tweaking to configure them, it's solely in this resource creation box. So an example of Terraform in action, you can see here their Terraform configuration language. We define a provider. We are making our launch configuration for our auto scaling group. Really straightforward and clear names. We have a name prefix. What's it going to be named with? What's the image ID that we're going to be building our nodes from? The instance type that you might be using. There's some also really sexy functionality that you can use that at a later talk to be able to build some dynamic configurations and share those configurations across your environment so that you're not necessarily hard coding everything. To go back to that dry principle and our extensibility and maintainability of our infrastructure code. Here we are using the launch configuration that we defined up here and to create our auto scaling group with a min size of 1 and a max size of 3. So why Terraform? Ease of use, increased readability and maintainability, continuing to go back and harp on those main principles of readability and maintainability. As you saw, it's cleared to go through and see exactly what I'm building. It's exactly described of what is going to be running in my production dev QA environment. They have really reliable and tested APIs for creating your infrastructure components. Ansible has the functionality to provision some infrastructure for you. However, the Ansible APIs to me aren't the most reliable, and that's an opinion, Bree's opinion, take it with a grain of salt. So Terraform to me just has some really tried and true tested APIs for creating this infrastructure. Cloud agnostic, again, going back to that caveat, if you were to switch to GCP or Azure in the middle of a project, yes, you are probably going to have to change some of your code, but you're not going to have to go and learn a whole new tool, how to implement and run that tool. Your automation for invoking the command doesn't have to change, just a little bit of specification. And you probably reuse some of the components that you already had. And then finally, what I really love about Terraform is that you can customize and add in your own providers. Anisha is doing a phenomenal talk later on today about creating your own provider. So you can do things like being able to set up connections to your own data center or set up a third-party connection like Cloudflare. You can configure Cloudflare right next to your cloud infrastructure environment and have it all stored in one place. I sometimes like to compare Terraform and CloudFormation. They're relatively similar, and I think my aversion to JSON makes me privy to reading Terraform a little bit better. But again, we have our Terraform example here, and then CloudFormation, and this doesn't even have everything defined. It's just a giant JSON blob, and I just think Terraform is a little bit more readable, more maintainable. You can extend it and add your own customizations that you would like. It also doesn't vendor lock you into AWS. So the last few minutes, we are going to look at the triple threat in action. I unfortunately cannot do a live demo. The time that it takes for all of these pieces and parts to run is just too long. The provision time, unfortunately, extends what a 35-minute talk would allow. But we can look at the code that I would use to build a true component of my infrastructure. So really big picture, architecture diagram. We have a web app and maybe an extension, and it talks to a bunch of different microservices, and those then connect to a variety of data stores. We have been tasked with building our Cassandra cluster. It is going to be a 6-node cluster, and it should be running in AWS. So I'm going to whip out my code. Everybody said that they can see this. We're going to start with our base image. So we had talked about we want to bake in everything that my Cassandra instance is going to need. So we can look at this Packer JSON. We had seen it before, defining some of the AWS configurations that we need. Here's my source AMI. I want any Ubuntu image, the latest, most recent Ubuntu image from my account owner. And then remember in this provisioner section, I said you can invoke Ansible. So first we need to install Ansible really quick, but then we just have to type that we're going to run an Ansible playbook, and we pass in the location to that Ansible playbook, and there you are, you're off to the races. So if we look at this playbook here, again, that hierarchical words, design of the playbooks and the roles. So I have this common and Cassandra role. We're only going to look at Cassandra today, but you know, common might be something a bunch of other playbooks would use when they're configuring their configuration code. So if we look at this Cassandra YAML, we're installing our Apache Cassandra with our package manager app for Ubuntu. And then, you know, like, again, going back to the simplified functionality that all of these tools provide, I can even pass, like, if you, for example, we store all of our artifacts in Artifactory, and I can pass a URL so that apt knows to get this installation from my Artifactory URL instead of from the main apt repository. And this, at the end of when I'm running this playbook, running my Packer JSON, I'll say Packer install this image. At the end of it, I will have an AWS AMI, Amazon Machine image, for me to use to build and configure those 6 nodes that we're building. So moving right along, we're next going to look at that configuration. So the dynamic frying side of things, right? What do I need to configure in order for Cassandra to be up and running and servicing my application? So again, it should look very similar to the Ansible that we saw before. We have some common functionality that we are using to dynamically set up across all of our boxes. And then we have our Cassandra playbook here. So, or Cassandra role here. So we're gonna look at the Cassandra main YAML. We stopped the service. We've seen the example of where we're mounting our EBS volume. We're waiting for that device to be present. I'm not gonna go through the nitty-gritty details of what each one of these things does out of sake of time, but for the example, we're copying in a properties file that enables us to configure this Cassandra cluster. And we're using not just copy, we're using a template, which allows me, if I look at my templates folder, it matches that, it's not fun, Etsy Cassandra YAML. It allows me to specify things like variables. So in the different environments that I'm running in, how can I change this Cassandra cluster name? There are other things like when you spin up a Cassandra instance, you're going to have seed nodes. And what are the IP addresses of those seed nodes? You can use a template to be able, at provision time, configure those seed nodes. Much better than going in and manually entering that into each one of your boxes. Imagine you had 12, 18 Cassandra nodes. I think one of our clusters has like 100 something Cassandra, which would just be a pain to edit all those. So there's a lot of features and functionality and configuration that we're getting out of our configuration code with Ansible, but we're gonna save this. We're not yet going to run this Ansible code because it needs to be coupled with when we provision our infrastructure, right? So in comes Terraform to help us with provisioning. Again, some of the setup required for Terraform, and then I'm just making, oops, this should be 6. And this is a great example on why you can use things like variables to define how many nodes should you have. Because here I have 6 now ENIs to attach to my nodes, but only 4 nodes. That's a bug in the code. But I'm going to be creating 4 nodes, and they're going to use my Cassandra AMI that I built in step 1 that will have Cassandra already installed on it. And then as their user data, we go down to this data section, it's going to source a template from shell script. So if I look at this shell script, all it does is it installs my Ansible script and then runs that Ansible playbook, passing in some of those, the Cassandra cluster variable that I'm anticipating I'm using. And with all of this, at the end of running TF apply, I will have 4 nodes. It should be, let's prefix this, 6 nodes with 6 ENIs attached to it. And again, clearly typo. 4 is not a great, I changed it from 4 because 4 is not a quorum consistent number for Cassandra. I should have a 6 node cluster that is perfectly installed and configured to run my Cassandra cluster and service my application. So with that, we've built a reliable, secure, and resilient, stellar infrastructure. Another caveat to you kind of have to do a little work on making sure that you provisioned your Cassandra correctly, right? If you leave Cassandra wide open, it also doesn't do your application any justice. But we've seen how we can build that maintainable, extensible infrastructure code by using these 3 tools. And hopefully, I've sparked a little interest probably engaged a little bit of questions and conversations for you to have with your teams or yourself. But I'd love, if we have time, I think we are at time, to take questions. I will stay around and answer any questions that we may have in the chat that come up. And with that, I thank you all so much for attending this talk. You can reach me at Twitter, maybe you can see my last tweets from 2018, or LinkedIn. You can email me, Briana at Women Who Code, especially if I have sparked some interest and you are like, how do I get hands-on with this? Sure, Bri, like I understand that this kind of makes sense, but why? It's so much quicker for me to go to the UI and make changes than to spend time writing code and up and running. Like, show me this hands-on. I would love to host a session with our cloud track if you're interested. So please reach out with any questions that you may have. And with that, I thank you. Are there any questions? I'll stay on here too, if that's okay, Mackenzie. I'll just hang out. Let's see if I can read any questions. And use
Hi, Briana.
Hi.
Hi, I'm your new moderator.
Oh, awesome.
So the other sessions are starting in just a few minutes, but maybe you want to, I pinned a question here from Saranya at the top of the chat. Do you see it in your session?
Yes. Can you use the Packer to make our system more secure? Yes and no, right? To me, security, part of the security that you're getting is an understanding of what is being set up, the traceability and auditability of what you're provisioning. But you still have to do in the work of understanding what you're configuring and making sure that how you are configuring your image is secure. So for example, I'm trying to think of a good example. If you install Cassandra, Cassandra comes out of the box with default user and password for your Cassandra database or your unit. And if you just install that and don't change it, like, to me, you're missing the opportunity for security or to have a secure Cassandra cluster. But being able to see each one of those components in your code and have it be code reviewed and discussed warrants for building a more secure software or secure infrastructure.
Great, thanks for answering the question. Just letting everyone know that there are more sessions that are beginning right now. Bri can be reached at the Twitter link, the LinkedIn, or Briana at Women Who Code. But yeah, thank you so much.